Okay. So, where we left off on Friday is what is the difference between theoretical probability and experimental probability? What does theoretical mean?
It's like a likelihood.
Okay. In other words, in theory, which means what?
Theoretical.
Theoretical and in theory are the same thing.
Okay. The probability of an event is the ratio of a favorable outcome of the number of
I want in your terms. What in the world does that crazy definition? So Marlon was a smarty pants and he opened this up and he said it's the likelihood that an event will happen. Okay, it's the likelihood that an event will happen. So, in other words, what should happen is your theoretical. Think about it. You flip a coin. What's the probability that it's going to land on heads?
1/2.
1/2, 50-50. Okay? So, in theory, that's what should happen. But if I actually held an experiment and we flipped the coin 10 times, who's got a coin?
Oh,
Anybody got a coin? Pull out your coin, Christian.
Pull it out. That penny drink gave.
Okay, we're going to flip this 10 times.
And I get.
Well, you don't gotta come.
Every time you get tails, girlie gets to slap you in the head.
Huh?
Oh,
yeah.
Okay, so hold up. Think about this. If it's 50-50 or 1/2, and I flip it 10 times, how many times should it land on heads?
5.
5. Half of it, right? Let's see what happens.
I said 9.
Flip the coin.
I know how to get heads off.
Tails.
Oh, I always get heads, get tails the first.
Heads.
Heads.
What if we get it actually 50-50?
He can be tails.
Side.
Heads.
Yeah, let's take a side.
Oh yeah, get sides, bro. Heads.
Totally.
Noggin.
Hey.
Yes.
Noggin.
Tails.
Heads.
Oh my God.
For real.
Probably tails.
I swear to God. That's tails.
Curry.
I don't flick it to the
Tails. Tails.
Kyrie.
Heads.
That's crazy.
Tails. Heads.
Okay, so according to this, what's the probability that I'm going to get heads?
1, 2, 3, 4. 8 out of 10.
8 out of 10, which is what?
80%.
80% or 4 out of 5.
Yeah.
Okay, you just told me that it should have been 50%. Okay, that's the difference between theoretical and experimental. Theoretical, it should happen. Experimental, that doesn't always mean that's what is going to happen. Why does experimental not always match theoretical?
Because that's what should happen. This is what will happen. Right.
But why? Why is it different?
There are different variables.
There's different variables.
Like he flipped it and it hit the ceiling and a light hit a floor and then a desk and then.
Okay. Human error is your biggest issue with an experiment. Okay? Not a single one of you is perfect. Okay? Not one of you. Not me, not Miss Curry, not Miss Harvey, not Mr. Kreisky. There is not a single human on earth that is perfect. So there is always a chance for human error, which causes the difference between theoretical and experimental. Does that make sense? Okay, so theoretical, experimental on the other side is the ratio of the number of times that an event occurs to the total number of trials. So when we flip that coin, we flipped it 10 times. So the number of times, this is your number of trials that goes in the bottom. Okay, how many times you perform the experiment?
3, 10, 5, 9, 7,
Okay, how many times did you perform the experiment? How many times did you flip the coin? How many times did you spin the spinner? How many times did you roll the die? Okay, and again, the number that goes on top, the number of times your actual event occurs. Good?
No. Not yet.
Boy, gonna shut up.
It wasn't even me that time. I still got yelled at. It wasn't even me.
Oh.
I keep my mouth shut, I still get yelled at.
Oh my.
That was deep.
All right. If you go to the example on the bottom left-hand side, the frequency table below shows the data collected from rolling a die 50 times. So if you're not used to reading a frequency table, what this means is we rolled the number 1 7 times. We rolled the number 2 5 times, so on and so forth. So this should total out to be 50 because it says we've rolled it 50 times.
Really?
Okay, so now we're going to find experimental probability versus theoretical probability. So we're going to do the probability of a number that is less than 5. What is the theoretical probability on a die that I will roll a number that is less than 5?
4 out of 6.
4 out of 6. Where did you get the 4 from?
There's 1, 2, 3, and 4.
Okay, you have 4 numbers that are less than 5. 1, 2, 3, and 4. Okay, so that gives you your top number of 4. Where did the 6 come from?
How many sides are on the die?
How many sides are on the die? So this probability is 4 out of 6 or 2/3. Let's compare that to the experimental probability. My experimental probability, my bottom number should be what? The experiment is what has happened in this chart up here. What should my bottom number be out of? 50. I've rolled the die 50 times, so my bottom number should be 50. What should my top number be this time?
Ah,
Shit.
you gotta add the top.
What number should go on top here?
Let's see.
How many times did we roll a number that is less than 5?
But watch.
We ain't even rolling less than
0.
How many times does the chart tell us we've rolled a number that is less than 4?
0.
Oh, snap.
0. We're looking at frequency.
According to this, how many times did I roll a 1? 7. How many times did I roll a 2?
5.
How many times did I roll a 3?
10.
How many times did I roll a 4?
9.
So how many times did I roll something less than
A
5?
lot.
31. Thank you.
31.
My fault. I had a mentally disabled moment, which I really am mentally disabled.
Thank you.
You're welcome.
I'm really mentally disabled.
Okay. So your experimental probability is 31 out of 50.
I did. That's a kid at first. Probably did.
Probably not.
I'm saying. She was gonna know the habit.
Check up in the top of the cupboard.
On top of the
There
cover.
should be more up there.
Donkeys.
Oh yeah, I got tons.
Speaking of donkey, I
Grab
seen
yourself a new box, friend, and open it.
This one is in the room. Do what?
Okay. Flip it to the other side. This time, we're rolling a pair of die. And we've rolled them 60 times, and we've recorded the sums in the frequency table below. So, I've rolled snake eyes twice for a sum of 2. I've rolled a sum of 3 times, so on and so forth. Okay, if you look down where it says theoretical probability, okay, they've given you this sample space because there's multiple different ways to get a sum of 3. I can roll a 1 on the first die and a 2 on the second, or I can roll a 2 on the first and a 1 on the second. Okay, so this is your sample space. I have one option to get a sum of 2. I have 2 options to get a sum of 3. 3 options to get a sum of 4, so on and so forth. So, what is the probability that I'm going to roll some sum that is greater than 6? What's the probability that I'm going to roll a sum that is greater than 6? Okay, first off, we need to come up with our bottom number.
60.
How many options do I have for a bottom number? Think about the rule that we learned on Friday. How many different numbers do I have on one die? 6. How many do I have on the second die? 6.
Oh.
So if I have 6 chances and 6 chances, how many total chances do I have?
36.
36. Thank you. The counting principle told you to multiply. So this is out of 36. There are 36 different numbers here in this square. How many times can I roll a number that is greater than 6? How many times? How many options do I have to roll a number that is greater than 6? What'd you say? 21. Okay, that's all your 7s. You've got 6 different ways you can roll a 7. That's all of your 8s. You've got 5 ways to roll an 8. All of your 9s. You've got 4 ways to roll a 9, 3 ways to roll a 10, 2 for an 11, and 1 for a 12. So that's 21 out of 36. Which actually reduces to what?
Why is that?
What are both of these numbers divisible by? What? 3. 21 divided by 3 gives me what?
Fail.
And 36 divided by 3 is?
12.
12. So this is a 7 out of 12. Okay, so that's your theoretical probability. You've got 36 different options. Okay, 21 of them are greater than 6. Okay, experimental probability. Remember, how many trials did I do when I completed this experiment to the left-hand side? How many times did I roll my die? 60. It says 60 in this one. It was 50 on the last one.
Oh, my fault.
Okay. This one's 60 times we've rolled it, so it's out of 60. Okay? Still the same probability. What's the probability of me getting something that is greater than 6? 5, 10, 15, 20, 25, 30.
Oh, 30 still. 38. 30. I got no 38.
I ain't getting no 21. I'll tell you that much.
38.
5, 10, 5, 10. We messed up for the
Y'all can't count.
You're right.
How many times did we roll a 7?
6.
Well, y'all can't.
Whoa!
Well,
Oh
it's
my
right
God.
there, bro.
Oh,
It's right there.
There's 14.
Y'all disabled. I was slow.
this is kindergarten.
No, the thing is, you're not paying attention. You're just shouting out what you want, and you're going to confuse everybody else.
No, he's probably counting from the table.
Because y'all
There
are
are
6,
6,
7
7
on the table. He's not counting the tally mark.
Okay, how many times did we roll an 8? 9 times. How many times did I roll a 9?
6.
10,
Oh.
11, 12. Okay, how many times did I roll a number that is greater than 6?
Bro, that's 30.
30.
That's 38. Gotta be 30.
38?
Because I was counting.
38 different times. What does this reduce down to?
One with it.
And if you're struggling with it, type it into your calculator. 38 divided by 60. Change your answer back to a fraction.
19 over 30.
19 over 30.
19 is a number? Didn't know that.
19.
Nah, that's what y'all-
What's 20?
I'm stop for y'all really gonna put me in a special education.
Okay, did your experimental probability match your theoretical at any point in time? No. Okay, normally if your experimental matches your theoretical, that's some kind of a miracle. Okay, you do not see it very often.
So really, that's
The more trials that you do, the better chance you have of matching it. Okay, but it's a very hard thing to match. Questions? Okay, this goes in on 154, friends.
You love me.
Yes, I love you. Why?
Damn, what I mean. Yeah, see, y'all teach got drama too. I'm a goose.
So, where you going today?
You just have to bottom.
I know. I didn't tell you.
See, what happened was he caught me on the bad day.
Poncho. I don't care. No. How dare
I bet y'all didn't know I was the lady.
Stop.
Close your eyes.
Close your eyes, man.
Whoa.
Okay. The notes we're about to take today also are a spin-off of Friday. Okay? When we did your deck of cards quiz, okay, we talked about things overlapping. Okay? That's the difference between mutually exclusive and the mutually inclusive. Okay? So, mutually exclusive, formal definition, 2 events that cannot occur at the same time. Okay? They're the ones that cannot occur at the same time. So, they don't share anything in common. So, a die and a coin, they don't share anything in common. Okay, if you're looking at a deck of cards, hearts and spades, they don't share anything in common. Okay, one's a heart, one's a spade.
Wait, they do because
Okay.
they're cards.
Go home, bro.
Okay, so when things are mutually exclusive, they don't share anything in common. So take a look at this one. What is the probability of randomly picking a number from 1 to 10 that is even, or randomly picking a number from 1 to 10 that is odd? So you've got two things going on. We're looking at even numbers and odd numbers. Do they share anything in common? No. So these are automatically exclusive. Even numbers are not odd numbers. Okay. What's the probability here of picking an even number? 1/2. It was 5 out of 10. I've got 5 even numbers out of a total of 10, which is 1/2. Okay, your 2 is even, your 4 is even, your 6 is even, your 8 is even, and your 10 is even. What's the probability of pulling an odd number?
5.
5 out of 10, which is again 1/2. When you have two mutually exclusive events, all you have to do is take the probability of each and add them together. So my first event was 1/2 plus my second event, which is 1/2, equals 1/2.
That's Charlie.
Think about it. If you look at the numbers 1 through 10, if I pick all the even and all the odds, that's every number up there, right?
Right.
Which makes it 1/2.
Witchcraft.
Okay. Okay. You roll 2 dice. What is the probability of getting a 2 on the first die and an odd number on the second? Okay, so we've got 2 and odd numbers. Do they overlap at all? Do they share anything in common? No, 2 is not odd, which again makes this exclusive. They don't share anything in common. What is the probability that I'm going to roll a 2? Trevor, can you give everybody else a chance to think and process? But you're the only one I'm hearing from because you're beating everybody to the punch. Okay, so 1 out of 6. What's the probability of an odd? We're talking about a die. How many odd numbers are on a die? 3 out of a total of 6. So your probability of an odd is 3 out of 6.
And that right there is 4.
Good. When we add it together, the probability of a 2 plus the probability of an odd,
Then it go down to 2/3.
Marlon just said was 4/6, and that reduces to 2/3.
I mean 2/5.
You can. I would have preferred to do it this way and left it out of 6 because when you add fractions, you keep that common denominator and then reduce it at the end. It just so happened that the one above, when you reduce them both, they both became out of 2, so they were okay to add together. But I would have left the one above alone too and did 5/10 plus 5/10 because then the bottom number is the same. Okay. Questions? 155.
That's Michael Jordan.
We've got one more, and then we've got a fantastic quizzes to practice.
That's what you said. You show. Positive.
Oh my God, I'm so happy.
You're real.
Really?
You ever been to Alaska?
Huh?
Have you ever been to Alaska?
No.
Yeah, I went there.
I go there every morning, second period. when I
Yeah.
go to sleep.
I went there before. Oh, that's I really did. I seen Mandy, Sid, Scratch, I seen everybody at Fight Station.
The only place I've never been off the East Coast. I've only been to Philly, New York, New Jersey.
Okay, so we just got done saying mutually exclusive events. The two events share nothing in common. What do you think mutually inclusive events mean then? They share something in common. So these are two events whose outcomes may be the same or they may overlap.
Oh,
Here comes that word overlap again from the quiz on cards. And these are called inclusive events.
there's $1,000.
So, your equation doesn't really change. You still add the two events together, but when they're inclusive, you then have to go back and subtract what has been overlapped. So, for instance, if I'm doing a 2, what's the probability of me rolling a 2 again on a die? Probability of a 2 was 1 out of 6. What's the probability of an even number?
3 out of 6.
3 out of 6. How many even numbers are also 2s? 1. So, 1 out of 6. This is a 2 and even. So the way we would do this is you would take the probability of the events and add them together. So you get 4 out of 6. And then we have to go through and we have to subtract that 1 out of 6 because I've counted it twice. I've counted the 2 here and then I recounted it here. I don't want it twice, I only want it once, so we have to subtract that overlap. So my final answer here then is 3 out of 6 or 1/2. Because you count it twice when you do the individual events. So if you look at the first example, one card is selected from a deck of playing cards. What is the probability that it is a club or a 10? Okay, so this is inclusive. What is the probability that I'm going to pull a club out of a deck of cards? Not 16 out of 13 out of 52. Remember, each grouping, each suit has 13 cards. So the probability of a club, there's 13 clubs out of 52 cards. I didn't say 10. I said club.
Oh, I heard club or a 10.
What is the probability of me pulling a 10 out of a deck of cards?
Ooh.
How many 10s are there in a deck?
4 out of 52.
4 out of 52.
So don't you add them up all together?
Okay, so 4 out of 52. How many 10s are also clubs? 1 out of 52. So to solve this one, you would add the two probabilities together. So your originals, 13 out of 52 plus 4 out of 52,
17.
which gives me 17 out of 52. And then subtract the fact that you've counted that 10 twice. You counted it as a club, and then you counted it as a 10. So we're left with 16 out of 52, which reduces down to what?
That should be
4 out of 13.
4 out of 13.
If you're not good with reducing in your head, literally 16 divided by 52 in your calculator. Use the math button to change it back to a fraction.
I'm gonna get there one day.
You're going to get there one day?
I'm gonna be smarter than anybody.
Smarter than a 5th grader?
I'm already smarter than that.
You're already smarter than a 5th grader?
Yeah.
You're trying to be smarter than a 9th grader?
I'm smarter than them too.
Okay.
Come on.
Yes.
Are you smarter than 5th grade?
Okay. Questions?
No.
Okay,
Now
this
let's-
glues in on page 156, my friend.
Now let's have nap time.
Bro,
Nap, please.
Bro,
see
you
Curry
better
on that show
Come
too,
on.
bro. Let's show you, bro. See Curry on that